see the unseen, change the unchanged. The innovation.
Hi, I'm geophysicist Ross Mitchell, and welcome to the video highlights of Volume 3, Issue 4 of The Innovation. The Innovation is clever to collaborate with professional artists for their eye-catching covers. And the cover of this issue makes that advantage bravely clear. You might be reminded of Van Gogh's Starry Night painting that inspired the cover of this issue. The pace of science and technology is accelerating. The future is arriving faster and faster than ever before. In this issue, The Innovation coins a new term called Science X to describe the now highly comprehensive and interdisciplinary network of science. The journal believes that the future of science and technology will determine our destiny. Sewage solution for carbon emissions. Can sewage, of all things, help us reverse CO2 emissions? Human-related emissions of CO2, a strong greenhouse gas, is a major contributor to global warming. Rising CO2 levels in the atmosphere is also leading to ocean acidification, as the ocean absorbs CO2 and its pH level drops. According to the recent IPCC report, it has been determined that emissions reductions alone are not sufficient or timely enough to avoid a global warming catastrophe. In addition, then, negative carbon emission technologies are needed to avoid atmospheric CO2 overshoot scenarios and limit global warming. In this issue of The Innovation, a commentary proposes a whole new use for wastewater. Wastewater has already been regarded for its potential for carbon capture, but this commentary goes one step further. It makes use of the fact that wastewater has high alkalinity, that it's a strong base with a high pH. Now, the details of why wastewater rich in dissolved alkaline ions also increase CO2 uptake and reduce degassing are a little complicated. The secret the authors figured out is the difference between dissolved inorganic carbon, DIC, and alkalinity. So can what we throw out really somehow help us out? More modeling is required to see if these local changes in ocean chemistry can apply globally. Big advances for big data. The world is simply generating too much data these days to rely on conventional methods of data analysis. Enter deep learning. Whereas an inflation in the amount of data creates processing problems for conventional methods, even machine learning, such redundancy can actually be used to improve decision-making. In 2012, a deep neural network, DNN, one machine learning method, was effectively trained on graphics processing units, GPUs, for phenomenal performance. The DNN mimics the complexity of our own biological neural networks. Many layers of repeated mathematical operations of the deep neural network can be matched well with the computational mechanism of GPUs. But this increased performance comes with limitations, huge energy costs, and a need for speed. As reported in this issue of The Innovation, deep neural network accelerators to the rescue. The DNN works in two phases. First, training, and then inference. Training involves simply feeding massive amounts of data into the DNN to achieve previously designed tests to update and parameterize the DNN and optimize its performance. Then comes the inference phase to predict the desired result with the input data. Inference consumes up to 90% of the energy cost of deep learning, making it the main concern for developing next-generation accelerators. I'll leave the details to those that are interested, but there is now a movement away from conventional electronics towards trainable physical systems. Limitations of electronics like heat dissipation, temporal latency, may always be the bottleneck for physical systems in deep learning. But seamless interactions between physical mechanisms and electronic accessories are expected in the future. But that's not all. There are many other topics covered in this issue of The Innovation that we haven't discussed in the video highlights. Make sure to check them out. Topics include artificial tooth enamel and beyond, why viruses are always one step ahead of us, CHES, a plan to detect Earth-like planets orbiting 100 nearby stars, and a new proposal to detect Earth 2.0s. A new patent for DNA sequencing and genotyping. Why is the Omicron variant milder? The pros and cons of COVID-19 for the world's oceans. Surprise receptor binding may help bacterial infections. Can we restore grassland sustainability? LASSO and the galactic cosmic rays. 15 years later, are China's sustainable communities working? Demethylation of reactions. CRISPR-Cas mammal gene editing. Hydrodynamic cloaking. Spin engineering of single-site metal catalysts. Clinical success in bile duct cancer. Cell-free DNA for early detection of cancers. Nanoparticles, print and assemble. Recent progress on fusion energy research in China.
Pursue excellence.